Welcome to doassignment-ca. Here is the problem. Two rockets start from rest at the same elevation. Rocket A accelerates vertically at 20 meters per second squared for 12 seconds and then maintains a constant speed. Rocket B accelerates at 15 meters per second squared until reaching a constant speed of 150 meters per second. Construct the acceleration time, velocity time, and position time graphs for each rocket until t equals 20 seconds. What is the distance between the rockets when t equals 20 seconds? Now let us work through the solution step by step. Rocket A starts from rest and accelerates at 20 meters per second squared for the first 12 seconds. Multiplying its speed at 12 seconds is 240 meters per second. After that, acceleration drops to zero and the rocket coasts at 240 meters per second for the rest of the 20-second window. On the acceleration time graph, this appears as a rectangular block of height 20 from t equals 0 to t equals 12, then 0. For Rocket A, Phase 1 uses the constant acceleration formula, 1/2 times 20 times 12 squared, which equals 440 meters. Phase 2 is simply 240 meters per second times 8 seconds, giving 1920 meters. Adding them together, Rocket A is 360 meters above the launch point at 20 seconds. Rocket B accelerates at 15 meters per second squared from rest until it hits 150 meters per second. Dividing 150 by 15 gives a transition time of 10 seconds. After 10 seconds, acceleration is 0 and the rocket coasts at 150 meters per second. On the acceleration time graph, this appears as a rectangular block of height 15 from t equals 0 to t equals 10, then 0. For Rocket B, Phase 1 gives 1/2 times 15 times 10 squared, which is 750 meters. Phase 2 is 150 meters per second times 10 seconds, which is 1,500 meters. Adding them together, Rocket B is 250 meters above the launch point at 20 seconds. On the velocity time graph, each rocket's curve rises linearly during its acceleration phase, then becomes a flat horizontal line once it reaches constant speed. Rocket A's horizontal line is higher at 240 meters per second, while Rocket B's levels off at 150 meters per second. On the position time graph, each rocket traces a parabola during acceleration, then a straight line whose slope equals its constant cruising speed. Both curves start at the origin and connect smoothly at their transition points. Since both rockets launched from the same elevation, the separation is simply the difference in their positions. Subtracting Rocket B's position from Rocket A's position, 3,360 minus 2,250 equals 1,110 meters. So at 20 seconds, Rocket A is 1,110 meters above Rocket B. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.